All right, everybody. So now we're going to go on to doing a heat release combustion problem. If you watched my last video, we did a calorimeter problem. So now let's do this example one of our heat release combustion problem. So we're given a reaction on the screen. And so it is C3H8, which is propane, oxygen, carbon dioxide plus H2O. So this is a combustion problem that we have here. We're given delta H, which is negative 2,200 negative 2,220. And so the question asks us how much heat is released from 25 grams of propane when 25 grams of propane is burned. So what should we first notice is that what we are given and what we want. So we are given 25 grams of propane. So let's write that down, 25 grams of C3H8. And we want the heat released. So let's write given here. Heat is our want. Our want is heat released. Okay, so now that we've round down what we have and what we're given, we must find the bridge between grams and kJ, and heat is always moles. So if we want to find heat, we have to find moles. But to find moles, we must balance our equation. So this reaction that we are given up on the screen is unbalanced. So we have C3, so we have 3 C's on this side. We have 8 H's on this side, and then we have 2 O's. And on this side we have 1 C. Let's go down. We have 2 H's and we have 3 O's. So to balance this equation, we're going to have to add a few numbers in here. So let's start off by balancing the H's. Let's start off by balancing the C's as we were taught. So to balance this C, let's see. So there's 1 C on this side. As you see, we have 1 C, so we would have to multiply this by 3. So let's add a 3 right in front of this C. And so that gives us 3 CO2. But since it's also next to an O, since it's CO2, that changes this to a 6. So now we have 6 O's on the right side. So now that we have, since we have 6 O's, we have 7 O's actually, including this one. We have 7 O's, including this O right here. So because we have 7 O's on this side, we have to have 7 O's on this other side. So let's put 5 here, and that gives us now 10 on this side. So now that we have 10 on this side, we need to get, let's go down and let's balance this H. So to balance this H, we have to have 4. Okay, let's put 4 H's, and that gives us to 8. So now we have 8 H's. We have 3 C's. We have 8 H's. And now let's see about these O's. So we have 10 O's on this side, and we have 3 times 2, that's 6. 4 times 0, which is 4. So now we have 10 O's on this side. So now this is our fully balanced equation. Let's move this down here. So we have C3H8. And this is a gas, plus 5O2 gas. That's our product side. We have 3CO2 gas plus 4H2O, and this is a liquid. All right. So now we have our balance equation. So now from here on out, we can convert our grams to moles using the molar mass that we were given earlier. So let's do, so we have 25 grams of propane. We have 25 grams of C3H8 times 1 moles, because we're trying to find the moles. So we have 1 mole of C3H8, and we could see this C3H8 right here. So we have 1 mole of C3H8 for every, sorry, I have the itch. And the molar mass of C3H8 is 44.11 grams of C3H8. C3H8. All right, so since we have this, we can cancel out these, and we can equal right around here. We have 0.5669 moles of C3H8. So those two units cancel out, the grams cancel out to leave us with the moles of C3H8. And this is our moles. Let me do that in a different color. Oh. So these are our moles. And so now that we have our moles, let's convert our moles to kJ. All right. So let's take a step back and see what we've done from here. So we found out what we were given. So we were given 25 grams of propane. And we want the heat released, as the question states, from propane. So from using those terms, we balanced our equation here. And with balancing our equation, we found our moles by multiplying our grams times our moles over our the molar mass of C3H8. And that's how we found moles of C3H8. So now that we have our moles of C3H8, let's multiply that by our Kj, which we're given in the problem as our right here. So we have our delta H, which is negative 2,222, negative 2,220 Kj. So let's do that. So let's grab down our 5699 moles of C3H8 times our negative 2220 Kj divided by 1 mole, because we have to cancel out these units of C3H8. So we cancel out the moles get canceled out. And then from there, we go equals, and this equals to negative 1258 Kj, because we're left with K and J here. We're left with K and J here. We canceled out our moles, so we're left with Kj when we bring it on to our answer. And so that gives us our answer, because since we were looking for our heat release, Kj will symbolize our heat released. So the burning of propane, let's write this out. The burning of propane releases, let's say released, negative 1258 kilojoules, which also tells us heat is exothermic because of negative symbol. So when we're given a negative symbol with our heat released, that means it is exothermic and that heat's released outward. And then we also have endothermic. So whenever something is our kJ, our kilojoules, our heat is positive, our heat is endothermic and it enters rather than exits, exo. So let's move on to example 2. All right, everybody, now that we've done example 1, let's move on to example 2. So this question is a thermochemical question, and we are given the reaction, and we're given delta H. And similarly to the last questions, we must ask what we are looking for and what we already have within our problem. So we, like I said earlier, we're given delta H, we're given an unbalanced equation, we're given the heat released from hydrogen gas, and we are asked how many grams of hydrogen gas must react to release 500 kilojoules of heat. So, unlike the last example from where we went from grams to moles to kilojoules, we're going in the opposite direction this time, and we're going to go from kilojoules, what we're given, to moles and to grams. So before we do that, let's balance this equation. So we have N and we have H, and on this side we have 2H and we have, 2N and 2H. And on the product side we have N1 and H3. So for us to balance this side, let's start off with the N to begin with. So we can, to balance this in, we can do 2 right here. And now we have 2N on the right side and N's match up. But now we have 6H. So we must balance the H on the left side by adding a 3. So let's rewrite this down just to make this a little bit more clear for us. So we have N nitrogen 2, and that is a gas, plus 3 hydrogen gas. And our product side, we have 2 NH3 gas. And let's just bring down our delta H. So our delta H that we were given in the problem is negative 92.2 kilojoules. All right, so now that we've balanced our equation, let's move on to step 2. So this was our step 1. Let's move on to step 2. So our step 2 is to use the mole ratio of H2 to convert our kilojoules into moles. So we have, this is actually, my question that I have here is actually, this is supposed to be negative 500 kilojoules. So we have negative 500 kilojoules times 3 moles of H2 hydrogen gas for every 1 kilojoule. Oh, sorry, that's wrong. We bring this kilojoule down. So the delta H, we bring this down. So we do negative 92.2 kJ. All right, and that gives us 16.27. We cancel out the kJ, cancel out this kJ, and we have moles of H2. So now we have our moles. So now from moles, like I said earlier, we're going from kJ to moles to grams. And this is what we're looking for, our grams. So now we grab our moles. We bring down our moles. Let's bring them right here. 16.27 moles of H2. We want to cancel this out. So let's put our 1 mole on bottom. And on top, we will put the 2.02 grams. This is our molar mass of H2. Remember, H equals 1.001. So 2H would be 1.001. 2.002. That's what we got. So let's do, we equal this and we get 32.9 grams of H2. So now that we got our molar mass, we are all done. So we've converted this to grams now. We've got our grams, and now from here, let's write out our final answer. So now that we have our molar mass in grams, it shows that for that 32.9 grams of hydrogen gas must react with 500 kilojoules of heat. So let's write that down. 32.9 grams of H2 must react with 500 kilojoules in order to release the heat of gas. All right. So Now that we're all done here, we've done our example 2, and here's our example 1. I hope everybody has a good one and a nice day, and good luck on everyone's test tomorrow. And also, I hope Mexico wins. We're at the 72nd minute right now. As I speak, I'm actually watching the game while I've been studying, multitasking, learning, really trying for this test 3. So, Professor, if you're watching this, please give me these 7.5 points. I've been trying really hard. Thank you guys. Good luck to everybody on tests. Have a nice day.